Permutations and Combinations by Morgan Miller. A permutation is an arrangement of n objects in a specific order. The permutation formula is n factorial divided by the difference factorial. N is the total amount of objects, and R is the objects taken out at a time. For example, a student can select 4 of 9 friends to go camping. How many different ways can the student choose her friends? According to our formula, we have a total of 9, which is our n, and the total amount at a time we are selecting, which is r, which is 4. With our given numbers, we plug it into our formula. We will get 9 factorial divided by 9 minus 4 factorial. Therefore, we'll get 9 factorial over 5 factorial. To simplify this fraction, rewrite out our rule of factorials. To simplify this, we have 1, 2, 3, 4, and 5 multiplied together to get 5 factorial. But in the upper denominator, we have 1, 2, 3, 4 times 5, the same numbers. If they're the same numbers, we can just cancel them out. All of these out. So at the end, we'll stick out with 9 times 8 times 7 times 6, which will get a total of 3,024. Combinations. Combination is a selection of distinct objects without regard to order. With a permutation, it did matter if it was in order, but with the combination, it doesn't matter. Our formula for combinations is n factorial divided by n minus r factorial times r factorial. For example, on a team, there are 5 women and 11 men. A committee of 2 women and 2 men must be selected. How many different possibilities are there? We are given that out of 16 on a team, we need a committee of 4. To do this problem, we must separate the men and the women and multiply to get the final combination. In our formula, we have plugged in our given numbers and we have gotten this. 5 combination 2, we end up with 5 factorial divided by 3 factorial times 2 factorial. And for the men, we get 11 factorial divided by 9 factorial divided by 2 factorial. As we simplify our given formula, we end up with these fractions of factorials. To simplify these, I like to write them out and cancel them out. So, by that, we see 3 times 2 times 1, but we also see 3 times 2 times 1 in the denominator. Therefore, we can cancel these out. Boom, boom, boom. And we'll end up with 5 times 4 times 2 times 1. Same with the bottom. We have 11 factorial divided by 9 factorial divided by 2 factorial. We have 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 in both the numerator and the denominator. So therefore we can cancel those out. We will be left over with 11 times 10 on the denominator and 2 times 1 in the denominator. At the end, we simplify our fractions even lower, and 20 divided by 2 equals 10, and 110 divided by 2 equals 55. Therefore, if we plug into our formula, we must multiply the 2 combinations. We got both numbers, 10 and 55. We multiply those together, and we get the total combinations. We get 550.